In episode 1 we learned how to look around. We could SSH in, list files and read them. But what happens when there are hundreds of files and you don't know which one you need? These 6 levels are about searching. Not clicking around hoping to get lucky, but asking the file system precise questions and getting precise answers. This is how real penetration testers do reconnaissance. This is how you find what was never meant to be found. Let's get right into it. We will connect to level 4 using our password from episode 1. We're logged in as Bandit 4. As usual, there is a directory called in here. There are 10 files named -file00 through -file09. Most of them are binary garbage. One contains the password. The challenge is finding the right one without opening all 10. The file command interrogates the actual contents of a file and reports what it really is, regardless of what the file name says. On real systems, extensions are cosmetic. An attacker can name a PHP shell, image.jpg. The contents mean everything. The asterisk is a wildcard, it matches anything starting with -file0, so file runs against all 10 at once. One reports ASCII text. The others show data. Let us read the ASCII one. And there we have it. The password for level 5. Level 4 done. Connecting to level 5. Logged in as Bandit 5. The in here directory is a maze, multiple subdirectories, each containing multiple files. The password file has 3 properties: human readable, exactly 1033 bytes, and not executable. The find command searches for files matching criteria you specify. Unlike ls, it descends into subdirectories automatically. Let us build it step by step, starting simple. Now narrow it to regular files only with type F. Now add the size, 1033 bytes. The C after the number means bytes. K would mean kilobytes, M megabytes. Querying the file type and size returns the file we are looking for. But let's learn how to exclude executable files with the not executable flag. The same file is returned. That is our target. Let us read it. This is the password for level 6. Level 5 done. Connecting to level 6. Logged in as Bandit 6. This time the file is somewhere on the entire server, not just the home directory. It is owned by user Bandit 7, group Bandit 6, and is 33 bytes. We start our search from root. First, let us see what happens without the error redirect. Watch what find from root looks like on a server you don't own. Hundreds of permission-denied errors for every directory we can't read. This is standard error, file descriptor 2. The to-dev null redirect sends all of it to a special file that silently discards anything written to it. One result is returned. That is the standard error redirect, and it will save you on every single system-wide search you ever run. Let us read that file. Here we have the password for level 7. Level 6 done. Connecting to Level 7. Logged in as Bandit 7. The password for Level 8 is in data.txt next to the word millionth. The file contains millions of lines. Opening it and scrolling is not an option. This is exactly what grep is for. Grep searches inside a file for lines matching a pattern and prints only those matching lines. The pattern here is the word millionth. One line. That is grep, instant result from millions of lines. In real penetration testing, grep searches recursively through entire directories for keywords like password, secret, key, or token. It is one of the most used tools in the field. Level 7 done. Connecting to Level 8. Logged in as Bandit 8. The data.txt file contains thousands of lines. The password is the only line that appears exactly once. Everything else is a duplicate. We need two commands working together. First, sort. It arranges every line alphabetically, putting all identical lines next to each other. Now the pipe. That vertical bar takes the output of sort and feeds it directly into the next command as input. No intermediate file. No manual copying. This is the Unix philosophy, small tools chained together. The head command is just to show the sorted output. uniq filters out all duplicate adjacent lines. The U flag means print only lines that are truly unique, appearing exactly once. Because we sorted first, all duplicates are already side by side. Just one line returned. That is the password. Sort and uniq solved a problem neither could alone. That is the power of pipes. Level 8 done. Connecting to Level 9. Logged in as Bandit 9. This one is different. Data.txt is a binary file. The password is hidden inside it as readable text, surrounded by equal signs. Let us see what cat does to it first. Binary garbage, and the terminal is a mess. Let's clear it. The strings command scans any file, binary or otherwise, and extracts every sequence of printable characters. It is a standard first step in malware analysis and binary reverse engineering. Still a lot of output, but we can pipe it through grep to find only the lines with equal signs. There, the password surrounded by equal signs. The strings command extracted the readable text, grep found the relevant line. This exact technique is used in real malware triage every day. Level 9 done. And that is all for episode 2. 6 levels, 6 tools, and one idea running through all of them. You don't browse a Linux system, you query it. Find doesn't wait for you to navigate to the right folder. Grep doesn't ask you to scroll. Strings doesn't care that a file is binary. You describe what you're looking for, and the file system tells you where it is. Episode 3 is where we start dealing with encoded and encrypted data, base 64, ROT13, and the beginnings of cryptography. If episode 2 was about finding things, episode 3 is about reading them once they're obfuscated. Subscribe if you want to follow the full series. Drop a comment with your questions and I'll see you in episode 3.